Some of the biggest challenges that we have, as part of being uh, the ground, um, the ground program, we are the ones that receive all the hardware where it gets integrated. So some of the challenges that we have are trying to make sure that the requirements that come from the other programs are well defined in advance. So when we go off and process, those requirements are clear. It's also challenging being as part of being GSDO because we get to integrate and test the flight hardware for the first time. This is the place where all the hardware is assembled and launch configuration for the first time. So we got to make sure that we are checking out everything that needs to be checked out in the vehicle and integrated properly. So we need to make sure that those requirements are well stated in advance. We have the proper planning. So, we got to work closely with SLS and Orion to understand, what are the test objectives they're trying to accomplish as part of integration. And GSDO has to figure out how are we going to go off and implement those requirements. Some of the other challenges we have is obviously, the cultural barriers that the hardware is coming from different parts of the country. So, it's essential to have that early integration to understand, define the requirements that are going to come with the hardware as it's delivered. So how are we going to accept the hardware? What open paperwork the hardware comes with to make sure when we're processing, we take into account all of that. It's also very important for us to understand how we're going to involve the design centers when we have a problem. We need to define those roles and responsibilities early on because we want to make sure that we take into account how the hardware was designed and assembled and what type of testing or what type of problems they saw while the hardware was being developed. And now that we're getting ready to integrate it and put it into an operational mode, that we're not seeing the same type of issues. I will say also that, going back to the integrated testing, we had a lot of lessons that we learned from ISS when we were doing the multi-element integrated testing on MEIT, where that was the first time we got to power up different of the ISS modules and put them together on an orbit configuration, and we start seeing a lot of issues, and we understood the importance of what we needed to test on the ground. So we have applied some of those lessons learned and work with SLS and Orion to help define those testing requirements of things that, it's a little different for a launch vehicle if you compare it with ISS, but, the lifespan, I guess, of when the rocket's going to be powered during launch, it's very short comparison to, ISS. But we need to, I think it's actually more critical because it's less time and more things that can go wrong in that specific launch countdown time frame. So it's important to test all those different components, interfaces, to make sure that they're verified and validated prior to we get to the launch countdown, when we only have a launch window that we gotta, be successful for. So we're trying to look at everything that can be tested beforehand. How far down the launch count we have to go. Do we need to go off and perform some type of tanking test to make sure that all the propulsion systems work correctly?